All right, so what we're going to be doing today is talking about rational expressions and functions, and we're going to be really comparing like fractions, rational numbers with rational expressions. So the biggest difference that you'll notice between a rational expression and a rational number is a rational number is a number like 2/3, 3 to the -3rd, or whatever the case might be. It's a number versus a rational expression more like looks like this, where it has a polynomial in the numerator and a polynomial in the denominator. This is math fancy talk for saying that. Okay, so a rational function is made up of a numerator and a denominator, where both of those are expressions, polynomial expressions. Okay, if these were just numbers like 2 and 3, then we wouldn't call it a rational function or a rational expression. We would actually just call it a rational number. Okay, so that's the biggest thing. It is important for you to understand the words and the verbiage along with it, right? Imagine you go into the doctor's office and he's like, yeah, I need you to show me the whatchamacallit. And you look at him and you're like, you are a doctor, you should leave. Like as soon as he opened his mouth and he said whatchamacallit, you leave. And you're like, but Miss Johnson, they're doctors, they're really smart. Yeah, but he just showed you that he's tired and he doesn't know what he's talking about. Do you really want him to help you? Everyone run out of the room. Okay, so the next one was this launch. And what it wanted you to do was it wanted you to compare simplifying a rational number or a fraction, and then apply that understanding to a rational expression. So we were just talking about how this is a very strong thing in math, where they take something like, say, simplifying fractions that right? You've known it since like 5th and 4th grade, and apply it to something new and different. And you see, does it work the same or does it work different, right? And so I'm going to be writing a lot, so I'm going to be going to my notes here. So really quickly, we're going to write equivalent rational expressions. We're going to find the features of rational functions with numerators that are 1 degree greater than the denominator. So if you remember from the last lesson, we talked about when the denominator wins and when they were tied, right? In terms of the degrees of the numerator and denominator. We forgot what, not we didn't forget. We separated this one out because it has a completely different thought. Okay, so when the numerator wins by 1 degree, only by 1 degree, Miss Johnson, then it's something really neat happens. And so that's what we're going to observe today. So it says, what does the graph of a rational function look like if the function has common factors in the numerator and denominator? Ooh, what will happen? Okay, and what does the graph of a rational function look like if the degree of the numerator is greater than the degree of the denominator? Okay, so we talked about this already in this. Okay, so we're going to be, so this is fill in the missing part. So we're going to do this part. So here, if you notice, some of you guys don't simplify like this. You're like, oh, these both have a 6. And so you can take a 6 out of that. So they laid it all out here because that structure is going to work here and here. So for those of you whose groups did not understand this one, your eyeball should be glued to the screen so that you do not miss this. So very often there's usually one part of the lesson that if you miss this, the rest of the lesson doesn't make sense, or even sometimes the rest of the chapter doesn't make sense. This is one of those things. Okay, so your job is to say, oh, that makes sense because it makes sense over here. So quite often Ms. Johnson says, if it works in number land, it'll work in rational land, right? And that's true for this case. That's true for adding, subtracting, multiplying, and dividing. Actually, dividing we already did last chapter, but you'll see that in the next lesson. Okay, so your first task was to factor this. I am not going to show you how to factor this because my assumption is that you remember. If you don't remember how to factor quadratics like this, go Google factor quadratics. There's a bunch on my channel. I show you a couple different ways to do it. It's fantastic. Okay, so here, can someone tell me the answer in the chat, please? X squared minus x minus 6. Can you factor that out for me? When I say the words factor, your brain should go like this. When I say the word factor, your brain should do this, parentheses, parentheses. So someone said x plus 2, x minus 3, and I'm just going to check to make sure. 2 times -3 is -6, -3 plus 2 is -1. Boom, this is right, right? So that's number one. So everybody okay with this so far, so good? Because the next part, I'm going to say that's probably the hardest part. The next part is very, very, very familiar. So the next thing I'm going to do is I'm going to copy all of this here. So I'm just copying x plus 2, x minus 3, x plus 2, x minus 2. And it says, divide the numerator and denominator by the same factors. What they're saying is here in number land, they're saying 2 divided by 2. Hey, what's 2 divided by 2? What's 2 divided by 2? Yeah, it's 1, right? 2 divided by 2 is 1. Very good. So Miss Johnson, she usually draws this like cartoon looking 1 right here. Do you guys all see my 1? This is just a big 1. So, and we all know, because it was our favorite multiplication table when we were younger, right? 1 times anything is that same anything. So it's almost like I don't have to write it. So same thing goes here, Miss Johnson. Can you make a 1 right there? Yeah, it'll just look funny, right? It's just sideways. Looks like a funny 1. So there's my 1. And so what I'm left with is 2 times 2, which is 4 times 5. I will tell you, Miss Johnson prefers to leave your answer in parentheses. Don't multiply out. Okay, that's not going to happen in this case, but you'll see what I mean. So does anybody see a 1 that I could remove? Does anybody see a 1 that I can remove in this section here? Yeah, x plus 2 divided by x plus 2, Miss Johnson, is 1. Miss Johnson, it works even with what is it called? With x's? Yes, right? X plus 2 divided by x plus 2 is 1. Sometimes they'll give you like some information at the very top that says, by the way, x can't be -2 or +2 or whatever would make the denominator 0. So I'm not even worried that this is not 0 or not undefined because of how they gave it to me. Does that make sense? But always have that caveat in your head that the denominator can never be 0. Okay, so if this is in fact 1, is 1 times x minus 3, everyone says yes. And is 1 times x minus 2 really x minus 2? And everyone says yes. Any questions on this? Any questions right here? Any questions? So go over in your head, like if this was a recipe, go over in your head. Okay, first I did, then I did. Here's the key step, and then I did. So from first step to second step, this is old stuff. If I had to place it, it would probably be an integrated 2 or integrated or algebra 1. I don't know if whatever class you took. This is when you learned how to factor, right? This is when you learned how to factor. Okay. If you don't remember how to factor, go back and learn how to do that. Okay. From here to here, I just copied it. Is this part new? X plus 2 divided by x plus 2 is 1. Is that something I had to teach you today? No, that's not new. So Ms. Johnson, there's nothing new here. Yes. So this is kind of like a mashup. I took your knowledge of factoring. I applied your knowledge of simplifying fractions, and ta-da, there's your answer. Nothing new today. Okay, we just applied it to something different. Everybody good on this? All right. With that being said, I'm going to pause really quick so you guys can factor this. I'm going to just give you a couple of seconds to do this because we do have to move on. All right. So now that you're back and we're factoring, so for those of you who need practice on factoring, practice. Okay, the only way that you're going to get better at factoring is if you practice. Again, we had this conversation. If you're using a tool to help you factor, that's fine. But again, that's like, that's how you missed out on here, right? How do I put this? If you're skipping the step of factoring and you're using some kind of calculator to help you do this, that's okay. But you're missing out on all of these like understandings. That's why you have to memorize steps instead of you really understanding what we're doing, right? Again, my boast for you guys is that you will never have to study for our math quiz or math test because you answer questions in class the whole time, right? And so I am curious if any of you do that. If you don't have to study because you've answered all your questions and that has really helped you. So I'm going to factor really quickly. I get x plus 3, x plus 5. On the bottom, I get x plus 6, x plus 3. And then I am going to copy this just so I don't have to write it again. Miss Johnson, I know, right? Look at that technology at its finest. Anybody see anything that we could do here? Anybody see anything that we could do here? Anybody see? Yeah, those x plus 3s, Miss Johnson, those two. People like to use the word cancel. I don't like the word cancel because cancel could mean 0 to someone. Cancel could mean different things. So I say I see ones, right? And because it's times 1, I don't need to write it. So there's my answer. This should make complete sense to you. Again, did I teach you anything new? Right? Most of you should say, no, I didn't teach you anything new. This should give you a good picture of what you need to work on tonight. Do you need to work on simplifying fractions? Do you need to work on factoring? If not, then you're good to go and you're ready. That's like, I don't need to teach the rest of this lesson. The rest of this lesson is just extra. All right. So it says, why does dividing the numerator and denominator by the same factor keep the value of the expression the same? What do you guys think about this? Why does dividing the numerator and the denominator by the same factor keep the value of the expression the same? Awesome. Answers here. Why? Why does it keep the same? So again, remember when we were talking about having you guys step up your game? That makes you stand out above Siri, above Google or any of these things. They can't answer this question, any of these why questions. Because you're simplifying the fraction, kind of, I need a more like a concrete answer. Why does dividing the numerator and denominator by the same factor give you, keep the same value? Because really, the value of what you divided is 1. And 1 times anything is that anything. So what I'm saying here is, how come this expression here is equivalent to this expression here? This is like a $20 bill. This is like 2 $10 bills, right? Why do they maintain the same value when you divide? Because you're really just factoring out 1. That's really what you're doing. All right. Number 3, if you were given the expression x over x squared minus 1, would it be equivalent if rewritten like this? Yes or no? What did you guys say? I was curious about this answer. What did you guys say? Here. Oh, no one answered number 3. Yes, it would. Someone says yes, because they cancel out. No, because, and no answer. So I didn't get everybody's answer here. That's all right. So if you don't know, I'm always going to encourage you to try. Just check. Okay. So someone give me a number. Please don't give me the number 1, because 1, you should all know why you shouldn't give me 1. You should all know why you shouldn't give me 1. Try whenever you're testing things. Also, don't test with a number 0, because 0 does very fun things too. So stay away from that. Hey, by the way, why did they say that you shouldn't choose the number 1? Someone gave me the number 5, so I'm going to use that. So 5 divided by 5 squared minus 1. Okay. Why shouldn't I be using the number 1? You should know this. You should know this. 1, what do you guys think? A bunch of people said no. 1% said no. A bunch of people said yes. 1% said no. So 5 minus, what do you guys say? Yes or no? Before I hit it, dun, dun, dun. 1 shouldn't be chosen because it will somehow equal 1 once divided. No. Why can't, wait, look, can we go back really quick? Why can't I use 1? Look at my expression. Why can't I use 1? Yeah, the denominator will equal 0. Dun, dun, dun. That should blow off like red alarms in your head, like, eh, like an annoying alarm, right? You can't have 0 in the denominator. You're going to hear me say that so many times. So many times. Okay, I hit the number 1. What does this tell me? What does this tell me? So this is another thing that your graphing calculator can't do. Your graphing calculator can't interpret these results. So why did you do that, Ms. Johnson? And how does that help me answer this question? If you were to get given the expression, could you cancel out those x's? So what answer should I write here? Yes or no? Uh-oh. We don't know. We got to be better. Someone take a risk. Be wrong. Say blue. Blue. Feel judged. Feel very judged. Just kidding. So the answer, yeah, very good. So someone put it in the chat. These two answers are not equal. Therefore, this is no. Exclamation. Don't do it. Someone said no because they don't equal the same. Exactamundo, my friend. Exactamundo. If these two values were exactly the same, it would mean that you could do that. Right? It means you could. Now, hey, Miss Johnson, what's the difference? Isn't x divided by x1? Isn't x divided by x1? So what's the difference? Why can't you do it here? And why can you do it here? Or why should you do it here? Should is better. This is pretty much where we're going to leave off, because once you hear this, then you can pretty much do the rest of the lesson. You can do your exit ticket. You could do everything. So anybody see the difference? I need your amazing, observing, young, beautiful eyes to observe what's the difference between this and this. What's the difference? Maybe make it bigger, Ms. Johnson, so they could see. Sure. What's the difference? Why can't I do it here? Why can I do it here? Why should I do it here? Okay, I need you to go back to like being like in 5th grade, right? In 5th grade, people would put, what is that, same difference, where they have 2 pictures that look exactly the same and your job is to find the difference. I think it's called same different. So I need you to find the differences between here and here. What do you observe? Someone said x squared is on the top for this one. Yeah, no, that's not the difference. Because look, here I canceled and here I could not cancel. Be like a young, like a really young human that says, oh, I see this, it's different. What's the difference between these two? It's very in your face. It's not, this is not convoluted. What is the difference between this up here and this down here? Come on, someone take a risk. You can do this. Yep, that's right. Someone got it. I'm not going to tell you though, because it might be to the point where I don't even tell you and I just end this video. Dun, dun, dun. And then that's what your job is, to find it. All right, 2 people got it. Can you tell me what is the difference? What do you see is the difference between here and here? Someone's going to say, oh, Ms. Johnson, this is x and this is x plus 2. Kind of, but not really. There's another difference. X doesn't have a number. That's kind of what I was just saying. X plus 2 versus x. No, that's not it. The square, no. X squared is not in parentheses. No. X and x squared don't equal 1. X, but they didn't take out x squared. They just divided x and x. So that's why it's 1 over here and x over here. No. The the thing that you were supposed to say is it's a physical thing that you see in front of your face. Like there's something that's different between these 2 things. Oh, is this going to be a cliffhanger? Cliffhangers are like when you say, tune in next time to see what happens. No? All right. Well, those two people know, and the rest of you know. All right. Tune in to the next time.